Hi everyone. In this video, I'm going to discuss how to carry out a one-way ANOVA with targeted plan contrast using SPSS. Analysis of variance basically involves comparing two or more group means on a dependent variable. Generally, it's utilized to compare three or more, but theoretically you could compare two. And basically, in those situations where you happen to have more than two groups involved, there might be circumstances where you want to test specific hypotheses about which groups are actually different on a dependent variable. So, for example, in this particular data set right here, I've got an independent and dependent variable. The independent variable treatment might be something like counseling intervention, reflecting different types of interventions. The dependent variable anxiety might be post-treatment levels of anxiety after a treatment period. You'll notice that in SPSS, the newer versions, it gives you these little icons here to designate the variable types. Under under variable view right here, I've got treatment listed as a nominal variable, and I've got anxiety listed as a scale variable. The scale basically is designating either an interval or ratio level variable. So it might be the case that I'm not only interested in determining if there is significant overall group differences on anxiety, which is what the ANOVA itself would actually do, but rather I might be interested more specifically in testing whether, say, the mean for group 1 is significantly different from the mean for group 3. Or something more complex, I might be interested in testing whether the average of the means for groups 1 and 2 might be significantly different from the mean for group 3 on anxiety. So in SPSS, there are a couple of ways that we can do this. The first route is probably the simplest route, but it provides a little bit less information than going through the second route. But I'm going to go through both ways in which you can generate ANOVAs and planned contrast tests. So if we go to compare means and go to one-way ANOVA, this is basically route 1. And so this box is going to open up. We move the independent variable to the factor box, and anxiety, in this case, our dependent variable, to the dependent list box. Now, under options, we can ask for descriptives, we can ask for homogeneity, variance tests, and so forth. We can ask for a means plot if we want. Under contrast, this is what we're talking about. When we're running a planned contrast, we have some a priori hypotheses about which groups differ. And there are two types of planned contrast. There are simple planned contrast, which involves basically a comparison between two groups. Okay, for instance, if I want to compare group 1 versus group 3, that would be, in terms of their means, that would be a simple planned contrast. If I was going to compare group 2 versus 3, that would also be a simple planned contrast. If I want to compare the average of the means from groups 1 and 2 against the mean for group 3, that would be a complex contrast because it involves more than two means. So I'm going to show you how to do each of those in this particular example. For starters, you'll notice that when you click on contrast, this box is going to open up. And so basically, this is where you are going to list certain contrast coefficients. So basically, when we're talking about a given contrast, it involves multiplying those contrast coefficients times the means for each of our groups. So essentially, you are assigning weights to each of the means, and then you compute the contrast. So basically, for instance, if I want to compare group 1 versus 3 in terms of their mean anxiety levels, the way I can do this, first of all, I've got basically my sample mean for group 1, sample mean for group 2, and the sample mean for group 3. So this is group 2, and then we've got for group 3. So basically, now I want to compare group 1 and 3, but I have to take into account group 2 being in the analysis as well. So basically, all I do is I create a set of codes that are multiplied by each of these means in order to lay out a comparison between groups 1 and 3. So very easily I can do this. First of all I have to do is think about it in terms of this. Basically, I just take 1 if I take 1 and multiply it by the mean for group 1 plus 0 times the mean for group 2 plus, and then if I multiply, and then if I take -1 times the mean for group 3, that's a -1. In that case, then I have laid out a contrast, because basically this would be a comparison of the mean for group 1 minus the mean for group 3. Because basically a negative times a positive is a negative. So this basically reduces to this particular contrast right here, the mean for group 1 minus the mean for group 3. If I want to compare group 2 versus 3, then in that particular case, I can use contrast codes of 1 and -1 here for groups 1 and 2, for groups 2 and 3, and 0 times the mean for group 1. So in a nutshell, it would look like this, and this basically is Greek letter psi, and in a nutshell, that's representing contrast. So in this particular case, I've got 0 times the mean for group 1, because we want to remove that group from the comparison, plus 1 times the mean for group 2, plus -1 times the mean for group 3. And like I said, that basically, if you take the negative here and multiply it times the mean here, it makes this a negative, and so basically it becomes the same as saying that we've got the mean for group 2 minus the mean for group 3. So, in a nutshell, that's the way that we could lay that out. So that's the mean for 2 minus the mean for 3. So that would be, say, a second simple contrast. Now, a third type of contrast that we could run is a complex contrast. So let's say we want to compare the average of the means for groups 1 and 2 against the mean for group 3. So we could lay that out, again, using contrast coefficients. So in this particular case, let's go back. Let's just say we got the mean for group 1 plus, right here, we'll say the mean for group 2. Maybe a little bit better handwriting here. It's very hard to do with a little mouse. And then we got the mean for group 3. So what would it take in order to generate the average of these two means against this mean right here for group 3? Well, first of all, we know that we're basically going to make this a negative regardless. So we're going to say basically plus, and we'll say -1 is our contrast coefficient for group 3, because we already know we're comparing the average of these means against this mean. So we'll make this -1 for this particular contrast coefficient. And so basically, if we want to take the average of these two means right here, well, we could just basically take 1/2 and multiply it times each of these means. Okay, so basically it would. So we would just say 1/2 and then 1/2 for this one, and there you go. The main thing to keep in mind is that the contrast coefficients have to sum to 0. Okay, so if they don't sum to 0, then there's something wrong. So basically, that's all we have to do. So we could then, so in this particular case, this is essentially the same as this right here. If we just say the mean for 1 plus the mean for 2 divided by 2, the average of those, minus the mean for group 3. And that's our contrast right there. So at any rate, that's how we utilize the contrast coefficients when we're laying out our targeted planned contrast. So now let's do this in SPSS. So in this particular case right here, for the first comparison, we're going to do a simple planned contrast comparing anxiety in group 1 against the mean anxiety in group 3. So we're going to make, for group 1, we're going to assign a 1. For group 2, we want to remove that mean, so we're going to assign that as 0. And then for group 3, we're going to assign a -1. And then click on Add, and then and so forth. And you can see that the coefficient total sums to 0. If we want to do our second contrast, compare group 2 versus 3, we can say 0 for group 1 plus 1 for group 2 and a -1 for group 3. And so there's our second contrast. We want to do our complex contrast. We can't type in like 1/2 right here. I can say it doesn't work. But what we can do is just type in the decimal form of our fraction. So we'll just type in 0.5 here, 0.5 for here, and then a -1 here. And so in this case right here, when I click on add, so you can see the coefficient total sums to 0. So we'll click on continue and then on OK, and so here's our output. So you can see that we've got, you know, our sample ends, our means, standard deviations for our groups, Levene's test associated with that's utilized to test the assumption of homogeneity of variances, which bears on our confidence in our ability to interpret the ANOVA results correctly. So you can see that the ANOVA we have a p-value at 0.002, which is less than conventional alpha level of 0.05. And so what we would do in that case is infer that there are significant differences across the groups when it comes to anxiety levels. Okay, so at this point, we'll scroll down a little bit further. And like I said, the ANOVA itself is really not as much of the focus as it is the planned contrast. Generally, if you come in with planned contrast in mind, you have some hypotheses that you want to test from the outset. The ANOVA is just sort of a step along the way. In part, you know, we end up taking the mean square from the ANOVA and using that in the construction of the standard error associated with these tests. That's part of the reason why we even care about the ANOVA. But at any rate, when we look at the contrast test, we've got two sets of options here: assume equal variances, do not assume equal variances. You know, probably a good bit of the time, you can basically assume that you have equal variances. Perhaps if the Levene's was significant, we might be thinking about utilizing these rows right here. But we're going to stick with this here. And so basically, contrast 1, you see the contrast coefficients laid out. So you've got treatment 1, 2, and 3. And so you've got contrast 1. And so these are the codes that we had assigned in SPSS. So we had a 1, 0, and a -1. For contrast 2, we had assigned 0, 1, and -1. So these are two simple contrasts. And then we have 0.5, 0.5, and -1 for the third contrast. So when we compare the means of groups 1 and 3, where it says value of contrast, this is basically taking the mean for group 1, subtracting the mean for group 3. And so in this case, we ended up with a -6.1667, meaning then that the mean for group 1 was about a little bit more than 6 points lower than that of group 3. You have over here, these are the p-values associated with your test. And the p-values are given for a two-tailed test. Under certain circumstances, if you're carrying out testing a directional hypothesis, which is what you can do with planned contrast, in certain circumstances you might choose to divide that p-value in half and use that sort of adjusted p-value for testing. But at any rate, in this particular case right here, we can say that there's a significant difference between groups 1 and 3 in terms of anxiety levels. When we compare groups 2 versus 3, you see right here the difference between groups is 2.8 points, with basically group 2 scoring about 2.8 points lower on anxiety on average than folks in group 3. Here's our p-value, and this was indicating for a two-tailed test, this would not be statistically significant. If I had a priori hypothesis in mind that the mean for group 2 might be lower than the mean for group 3, then I would have formulated a directional hypothesis, in which case then that would involve splitting this p-value right here, so the p-value would be 0.033, which would be less than an alpha level of 0.05, and so in that case I would be able to reject the null. The last contrast here is taking the average of the means for groups 1 and 2 and subtracting the mean for group 3, so looking at the difference there. So you can see right here that the average of the means for groups 1 and 2 is about 4.5 points lower than the mean for group 3. And is that difference significant? With a two-tailed test, it would certainly be statistically significant. So at any rate, that's basically a quick overview of running plan and contrast using sort of route 1 or the simpler route in SPSS. Now let's say I want to run my analysis using an alternate route, which would incorporate a little bit of the use of syntax. Don't get too scared by it. It's not really that bad. If you go to general linear model, univariate, this box will pop up. We put our independent variable here in the fixed factors box, anxiety in the DB. I can ask for more information. I can ask for descriptives, effect size, power, homogeneity tests, and the like. Under plots, I can ask for a means plot if I wanted to. Just move the independent variable to the horizontal axis, click add, continue, and there you go. There are certain canned contrast options in SPSS. I really don't like to utilize these particular options, but there are, I might be interested in using, say, a polynomial contrast if I have an ordered independent variable. Then in certain circumstances that might be useful. But some of these options are a little bit, I guess you could say, dated, and really it's sort of it's not particularly useful in my opinion. So I'm going to forget all about that, and let's just go to asking for our targeted plan contrast using our contrast coefficients. Now the best way to do this is click on paste. And what's going to happen when you click on paste is a syntax file is going to open up. And you can see in the syntax file all this information right here. This is everything that you specified by way of the menu options. So that's one of the really neat things about using that paste function is you don't actually have to know a lot about syntax in order to get everything up to this point. And then it just involves a couple of tweaks to the syntax in order to get our plan contrast run. So first of all, notice just a little bit of a background. You'll notice the first line, it says uni ANOVA anxiety by treatment. And so basically, this is the command for the invariant ANOVA, and anxiety is listed where the dependent variable name is going to fall by, and then this is the name of the independent variable. So basically it's saying anxiety is a function of treatment. You'll notice that that's for the profile plot, that's there. Various tables and so forth. There's eta squared, descriptives, and so forth. Down here where it says design, it's giving you the independent variable here, and you'll notice that at the very end, there's a little period. So if I remove that period, you'll notice that this right here turns from blue to red, and that's, so if I was to run the analysis at this point, I'm going to get an error message. So when I put the period back, you'll see it goes back to blue and all is well. Now, if I want to actually run the plan contrast, then I have to basically add a couple of lines to this particular syntax. So I'm going to go back, and you'll see it remove the period. So now it's showing up in red again. So I'll go to the next line, and I'm just going to space over one, and I'm going to use what's called an L matrix command, and basically that involves a \L, and you can see already it's starting to try to fill it in for you, and so you can either type it or let it fill in, but that's basically what it is. So I can give each contrast a name if I want, or something like that, and the way that I can do that is to put whatever name of it in quotation marks. I'm going to put quotation marks. I'm going to just say compare groups 1 or group 1 versus 3, and then end quotes. So without the end quote, it's going to turn red. With the quote, it turns back to black. And then, so I don't have to put a title in here if I don't want to, but it's kind of helpful in terms of finding things later on. So then I'm just going to type in the name of the independent variable. So I'm going to call it treatment. and then my contrast codes. And they're going to be basically, we're going to start off by comparing groups 1 and 3. So we're going to start off with 1 space 0 space -1, and then period. And so at this point, adding the period, this turns back to blue. So then I highlight, or actually I don't even have to highlight in these newer editions. So I can just click, well, maybe I do. Click on the, or highlight everything, press the green button, and there you go. And so you can see in our output, you've got our means, standard deviation, sample sizes. There's Levine's test. You'll notice right here, you've got the independent variable name treatment. And, you know, so basically, all that information we had seen before with going through Route 1, we see it yet again. So at this point, you can see that we've got down here, our tested between suffix effects. This is the name of our independent variable, and so we're going to interpret, you know, basically this line right here. So here's our F value and our P value associated with the test of overall group mean differences on the dependent variable. And so we're going to interpret this to mean that there are significant differences among our groups with respect to anxiety scores. So kind of scrolling down a bit, forget it, scroll down, you can see we have our custom hypothesis test. And so this is where the planned contrast is. And so, you know, basically by providing that little label or name in there using quotation marks, then it shows up at the bottom of the file, so or the table. So that's actually handy in terms of finding things later on. If you don't include that, it'll just say, you won't have a reference for what you did. If you're saving your output file for future reference, it's always nice to have a label involved. So the contrast estimate is basically taking the mean for group 1, subtracting the mean for group 3. So this is basically the computed mean difference, and this is our p-value for a two-tailed test. Like I said, if we're testing a directional hypothesis involved that would require a one-tailed test, and that might on occasion involve splitting that p-value in half. But basically, assuming just basically testing this out, we can say that the mean difference between groups 1 and 3 is statistically significant. Now, let's say we want to go a little bit further, and let's say we want to add in our next contrast. So I'm going to get rid of the little period here, and basically just type in \L matrix. And in this case, I'll say compare group 2 versus 3, and in quotations. Then type in treatment, and then you can say 0, 1, and -1, and then period. So again, you know, these contrast coefficients have to sum to 0. So in this particular case right here, I'm just going to highlight run. And so now what we see in our output, you'll see that basically there's the 1 versus 3, and let's see what happened here. I'm not sure if I actually ran it all. After a while, a lot of these things start to get a little bit tricky. So that's 1 versus 3. So let me see here. We had our L matrix command. Well, I'll just go ahead and take this out for the time being, just to make things run a little bit more smoothly. So basically highlighting and running, and in this particular case right here, you can see that we've got our comparison between group 2 and 3. So there's our label again. This is the difference between groups 2 and 3. So the mean for group 2 minus mean for group 3, that's the contrast estimate. And this is our p-value. Again, this is for a two-tailed test. So at any rate, there you go. Now let's try one more. Let's try our complex contrast. And so in this particular case, I'm going to type in L matrix, compare average of 2 and 3 versus, average of 1 and 2 versus 3. And then I'll say treatment, and I'll say, in this case, I'm going to use 1/2 1/2, and then -1. So this is going back to what we had seen before. I could have put in 0.5, 0.5, -1. That's fine. But this works just as well. So now I'll highlight and run. And so in this particular case right here, you can see I've got my 2 contrasts. This is just saying this is what was run. You can see contrast test 1, which is basically the pairwise contrast that we had before. So there's the mean difference. There's our p-value. And then you have, scrolling down, our complex contrast. So in this case, the average of the means for groups 1 and 2 is about 4.5 points lower than the average for group 3 when it comes to anxiety. So that's the difference in means that was computed, and then here's our p-value. So this result is exactly the same as what we had above when we ran through Route 1. So at any rate, that pretty well concludes this overview of one-way ANOVA with planned contrasts.